Okay, this is the first lecture for the module visualization. In this lecture I will show you, I will explain the general concepts behind VTK, and I will show you how to make your first simple VTK program. I will not go into many details because you can look them up yourself. It's more about the general concepts to understand what you are doing. VTK is short for Visualization Toolkit. That's a toolkit, a library that we use to visualize data. So imagine you have a big set of data, which is basically numbers, and you want to show that to somebody. Showing that person the numbers is not going to be very useful because people have difficulty understanding numbers. So what you want to do is you want to show it in a graphical way, using colors, using objects, using light and shapes, so that the meaning of the data is easier to understand for people, and they can immediately see, for example, if temperature is too high, because you can show that with the red color, or you can show a trend in data using a graph or things like that. When you start using it, you will see there are a number of similarities with VIS. We will talk about transforms, we will talk about colors, about textures. But the goal of VTK is different. VIS is a tool, or Unity is a tool that we use to create a virtual world. And VTK has as a goal to visualize data. So there are similarities. There is an overlap between the two tools, but VTK clearly has a different goal. VTK is freeware, one of the reasons that it's quite popular. It is used commercially in research and in development. The company behind it is called Kitware. Kitware made VTK originally in C++. But what we will do is we will use Python, because you know Python from previous courses. You can also choose another wrapper like Java. If you prefer Java, you can use that. But in the examples, I will always use Python. How does VTK work? Well, VTK is built like a pipeline, which means that we have data. It starts with data. We want to visualize data, and the data flows through a pipeline, and in the end it comes out as visual things, visual objects that we can see. And the pipeline consists of a number of stages. It always starts in the beginning with a source of data. So you can read data from a file, you can calculate data, and there are other ways to get the data, but that's what we call the source. That's the first stage of the pipeline that somehow gets the data and pushes it further into the pipeline. Then we have a filter stage, because not always we want to use all the data. Sometimes we want to filter data because it's too much, or it contains parts that we don't want to see. That's the second stage of our pipeline. It's optional. We don't always have a filter stage. We always have a source, but not always a filter. But it can be added to the pipeline. Then our goal is to show data as visual objects. The third stage in the pipeline is a mapper, which converts the data into things that we can see. And then those things are called actors. So we can show data, for example, like a cube or a sphere or another object, and then that cube or that sphere is called an actor, and that's an object that we can see. It has properties, like we can define a color, we can make it transparent, we can give it a texture and other things. So this is especially the stage where the similarities with VIS become clear. The actors have to be shown on the screen, so they have to be rendered. So the rendering is the next stage in the pipeline, where things like a light and a camera is added. So then we define the point of view from where we see the object, and we shine a light on it to make it visible. And then finally we have to show it in a window, and that's called the rendering window. In this figure you see these terms. You see, for example, here we have one window which contains two parts. So there are two different views, but in this case we call it renderers. In one view we see a pyramid, a cone, and in the other view we see a sphere. And here's another window, smaller window with only one renderer in it that shows us a cube. So what we can see from this picture is that inside one rendering window we can have two renderers, left and right, two renderers defined. The things that we see, the cone and the sphere and the cube, that are the actors. In VTK they are called VTK actor, that's a class we use for that. Actors have properties like color. We have a blue cone and a red cube, but these colors are defined with a VTK property. We have the mapper that makes the connection between the data and these objects. Each renderer has its own point of view, its own camera. So for this renderer we have a camera defined, and for this one also. And all the objects are illuminated by lights, so every renderer has its own camera and its own lighting defined. Here we can see the pipeline in a more visual way. You see the same stages that I explained before. We have the source of data, we have optional filter, we have a mapper that converts the data, this is the data part, into visual things. That's the lower side of the pipeline. You have the actors, you have the renderers and rendering window. They are here shown as one stage. And further down we can also add user interface controls, which we will see later. So you have the data processing segment of the pipeline, we have the rendering segment, the visual part, and we have the connection between the two, which is the mapper. Let's see, this is the concept. This is what you should have in mind when you make a VTK program. It always has this kind of pipeline with stages. This is what it looks like in code. Every stage is an object of a certain class, so we have a source. The first stage is created here. This is how you create an object in Python. Here in this example we use a cone source. That's a kind of source that calculates data on the spot. So you don't read the data from a file as you would usually do, but this kind of source, the VTK cone source, calculates the data right now. At the moment that data is needed, it's calculated. This calculates points in 3D space that represent the cone. You can define what the cone will look like, what the height will be, what the radius will be, what the resolution will be. So that's what we do here. Then in this case we don't have a filter. The filter is optional, we don't have it in this simple example. So the next stage in the pipeline is the mapper, which we here define as a polydata mapper. That's what a kind of mapper that maps data to polygons. It can be seen on the screen. How do we connect these two stages, the source and the mapper? Well, we do that with an input connection. So the input connection for the mapper is connected to the output of the cone. That's what connects this source to the mapper. Then we go to the next stage, which is an actor. So we have a VTK actor object created here, and here again we connect the actor to the previous stage in the pipeline, which is the mapper. So this actor has a mapper set. This connection is not using an input connection or an output port, but this is by setting the mapper. Every object has a mapper, one mapper, so we set the mapper here. The mapper for the cone actor is the cone mapper. Next stage is the renderer, so we define a VTK renderer object. We can set different properties or features of this renderer, like the background color set here. And we can show different actors in the same renderer. So we add an actor to the renderer. Notice the difference between this set mapper and add actor. A set mapper means every actor has exactly one mapper, so we set that mapper here. But every renderer can show different objects, different actors, so we can add multiple actors to the same renderer. And then we show it in the rendering window, which is created here, VTK render window. We can set the size for the window, and then we can add a renderer to the window. So what is shown as one stage here actually are also two different stages. First we have the renderer, and then the renderer is added to the window. Also add here, because as we saw before in the previous slide over here, in one window we can have two different renderers. So that's why in this case we use add renderer. We can run this code in Python. Here's the tool that I will use to show you the Python programs. It's called Spider. There are many tools that you can use to run Python scripts. We in the assignment, in the lab assignment, we advise you to use this one. But if you prefer another one, that's fine. In Spider, I'm going to run the code that we just saw in the slides. So I will create a new Python file, and then I will copy the code that we saw here into this Python file. Here it is. Here there's one weird character because of the copying from PowerPoint that I'm going to remove. We can run this by clicking on the Run button. I have to save it somewhere. Okay, put it on my desktop. But yeah, first you get this message, no Python console is currently selected. So it doesn't run. You can fix that by going to the run settings. Specify that it must be executed in the new Python console, and then run it again. And yeah, this is what we see. Actually, we see nothing. If you look down here in this area, you see that something happens. If I click on the run button over here, there is a stop button created for a short while, but it disappears immediately. And most importantly, we don't see anything. Why don't we see anything? That has to do with the nature of VTK, because VTK is what we call demand driven. The pipeline that I talked about before, which has a data source in the beginning and a render window at the end, it operates in a demand driven way. There must be somebody pulling data out of the end of the pipeline. So it's not like that the source is pushing the data into the pipeline, but there must be something pulling data out at the end. Data is generated only on demand, and we don't have such an operation yet. There's nothing at the end of the pipeline. Oh, here's the code again. There's nothing down here that activates the pipeline. How can we fix that? By simply adding a render operation. So at the very end of the code, adding a render operation, then that render operation will start pulling data out of the pipeline in order to show it in the window, and then we will see something. So we need to add this win.render statement, pulling data out of the pipeline at the end. So let me add that. So here at the end, run win.render, and run it again. Now you see, if you watched closely, I will do it again in a minute. You see a window, and if you look very quickly, you can even see that it has a cone inside. Why do we see this? Because this render operation, it will pull data out of the pipeline once. So the pipeline will be activated once, showing one frame of the cone, and that's it. So it does not repeat that operation. We see only one flash of the cone, and that's it. Not really what we want. We want our objects to stay visible on the screen. So, yeah, what do we have to do to get that? We have to add something that keeps on rendering the window. What we could do is put the render operation in a while statement or a for statement, so that it's repeated. But a nicer way is to add this, what we see here, the render window interactor. This will call the render operation repeatedly, so it contains that while or for statement, but it also adds interaction possibilities. So it will enable you to interact with your window. And like here you can see it enables some key presses, J and T, to toggle between joystick and trackball mode. Just try them and you will see the difference. In joystick mode, a movement will continue as long as you press the mouse button, and in trackball mode, when you start a certain movement, it will happen only when you also move your mouse. You can also toggle between C and A, camera and actor mode. In camera mode, with your mouse you can move the camera position. In actor mode, with your mouse you can move the object. And if you have multiple objects, you move the object under the mouse pointer. Left mouse button, LMB, rotates the camera or the actor, depending on the mode that you chose here, C or A. So with your left mouse button you rotate one of the two. With your middle mouse button you can pan the camera or move the actor. And with your right mouse button you either zoom your camera, you move forward and backward, or you scale the actor. And there are more. With 3 you toggle in stereo mode, with E or Q you can quit, with F you fly to the point on the cursor, you can reset your camera and so on. I just try them to see what they do. How do we add such a render window interactor? Well, we create one, create the VTK render window interactor, and then set the render window. Every interactor belongs to one single render window, so here you have to set it and not add it. Then initialize it and start it. So it's a number of steps. I will add this code to the program. By the way, the render window interactor does the rendering. It calls the render method, so we can remove it here. And if we now start it, you see the window stays visible. The program doesn't stop immediately, and for example, if I click the left mouse button, we see this rotation. The left mouse button was rotation. Middle mouse button was panning, right mouse button was zooming. So now you can interact with your window. And this is put at the end of the pipeline. What else can we explain? Yeah, an actor, as I mentioned before, has properties. Think about color, transparency. Are the edges visible or not? What you would expect is that you can set these properties immediately on the actor. Like we had a cone actor in this example program. You would expect, here, that if we have this cone actor, that you can set color, for example. But that's not how it works. The cone actor itself does not have a set color or something like that. What you have to do is, in that property object, you can set the color. So, in order to set a color, we have to first create a property object. Property. And then in that prop we can set the color. It's capital S. Red, green, blue. So if you want to make it red, it would be like this. And not cone actor.set color. If we do this, then the property, the color is set in the property object, but that has nothing to do with the actor. So we have to make a connection between the actor and the property, and that's by using the set property method. And if we run this, we see a red cone. Yeah, as you see, I made a mistake. Again, it's not Java. The methods, they start with a capital. And now we have a red cone. So that's how changing that kind of properties work. Not directly on the actor, but on the property, and then the property is set on the actor. About the camera is very much connected to the renderer. Every renderer has a camera, because that defines the point of view from where you see the objects. What is very typical in VTK, and also confusing at first, is that the camera does not have a fixed position, like always in the origin 000, or always at eye height, like in Visit. The camera is always on 001.8, so 1 meter 80 centimeter above the origin. But the camera in VTK is always positioned in such a way that you can see all the objects. And all the objects, all the actors are centered in the image. And the camera is also always looking down the positive Z-axis. That's confusing because if you move your object with a set position, then it seems as if nothing happens because the camera, when you start up your program, the camera will always move with it. This is the initial position of the camera. So when you start your application, the camera will always be positioned such that the actor is in the center of the image. Yeah, we can change the position always by using set position and set focal point, the point that it's looking at. But by default, if you don't do anything, by default the camera is positioned in such a way that all the objects are in the center of the image and filling the image also. So if you move your object far away, the camera will also go there. But that's only the initial position of the camera at startup. If you move your object after starting up the program, then the camera will not follow the object. It's only at startup the camera will be positioned so that you see all the actors in the center of the image. Camera can be moved in 6 different ways. We can move the camera around the point that it is looking at the focal point. Like here with these methods, roll, elevation, azimuth. So the camera is looking at this point, that is the focal point. With an azimuth operation, the camera rotates horizontally around that point. So it keeps the point in the center of the image, but it moves around it horizontally. By changing the elevation, it moves around the object vertically, but it keeps looking at the object. The object stays in the center of the screen, but the camera moves vertically around it. Or roll means the camera is rotating around its own axis, but still keeps looking at the object. So that are 3 movements that we can do with the camera. Or you can also do a roll, pitch and yaw. That means that the camera stays on the same position, but it rotates. So like the green pitch here, it means the camera will stay here. It will not move around the object like before. It will stay in the same position, but it will start looking upward and downward. So the object will go out of view. After with a pitch, if your pitch is big enough, so then the camera might be looking at this point. So then the object will go out of view. And same with a yaw. If you do a yaw to the right of your camera, you will see the object disappear to the left in the window. And the roll is the same as before, so actually we have 5 different operations. We can also add lights. There is a VTK light class. There's always a light on the camera position, the so-called headlight. So we can always see an object, even if we don't define the light ourselves because of that default headlight. But we can add new lights later. Okay, here are some simple VTK or Python things you can do, how to make a for statement, how to sleep. And there are 2 links here, maybe not so well visible, but there are 2 links here where you can find VTK examples.